Welcome to this explainer. I am absolutely thrilled to have you here. Today, we're embarking on a really rewarding, highly technical maker's journey. We are going to be connecting an Arduino UNO R4 to an HC-SR501 motion sensor. Let's get right into it. So, think about the very last time you walked into a grocery store. You know how those glass doors just sort of magically slide open right before you take a step inside? How do those automatic doors actually know you're there? It feels a little like magic, doesn't it? But actually, it's a highly accessible piece of technology. Today, we're going to reveal the mechanics behind that everyday mystery. And by the end of this explainer, you're going to have the exact tools and knowledge you need to literally build it yourself. All right, here is our roadmap for today. First up, the PIR principle. Second, we'll cover wiring the hardware. Third, programming logic. Fourth, advanced sensor settings. And fifth, our application, building an auto door with a servo. Let's dive right into part 1, the PIR principle, demystifying the technology. We need to understand the core mechanics here before we even think about touching any hardware. The HC-SR501 is what we call a PIR sensor, which stands for passive infrared. You see, humans, animals, we are all essentially walking heat signatures. We naturally radiate heat, and, well, in the world of physics, this heat is infrared energy. Now, this sensor is passive because it doesn't shoot out lasers or, scan the room with its own beams of light to find you. Nope, instead, it just sits there, passively waiting and watching for any changes in the infrared light coming from objects in its environment. Now, for the sensor to actually trigger, two very specific conditions have to be met simultaneously. First, the object has to be shaking or moving, and second, the object must be releasing infrared energy. What does that mean in practice? Well, if a little battery-powered toy car drives past the sensor, it won't trigger it, simply because a plastic toy car isn't emitting body heat. On the flip side, if a human being stands perfectly, completely still right in front of the sensor, it also won't trigger because there's absolutely no movement. It literally requires both heat and motion to work. Okay, let's move right along to part 2, wiring the hardware, connecting the sensor. Let's see exactly how we link the HC-SR501 to our Arduino UNO R4. This is a very clean 3-pin wiring setup. The HC-SR501 is incredibly straightforward to wire up. First, you just connect the sensor's GND pin to the Arduino's GND pin. That provides our 0-volt ground. Next up, the VCC pin connects to the Arduino's 5-volt pin, and that supplies our power. And finally, the output pin on the sensor connects to any digital input pin on your Arduino R4. When the sensor detects absolutely nothing, this output pin just sits at a low state. But the second it detects human motion, boom, it jumps up to a high state. With the hardware fully wired up, we reach part 3, programming logic, reading the sensor. So, let's take a look at the actual C++ logic that makes the Arduino understand all that incoming data. In our setup phase, we use the pin mode command to basically prepare the board. We're telling the Arduino, hey, the specific pin connected to our sensor is an input. Basically, we are listening for data. Then, down in our main loop, we use the digitalRead command. This tells the board to constantly listen to that pin and then store its current status, whether that's high or low, into a handy little variable we call motion state. Now, to catch the exact moment motion begins, the Arduino actually compares the past to the present incredibly fast. It's really cool. If the prev motion state, meaning what the sensor saw just a microsecond ago, was low, which means the room was completely empty, and the current motion state is now high, well, then we know for an absolute fact that motion has just started. The Arduino can then immediately print motion detected right to our screen. But before we actually go ahead and build our final project, let's look at part 4, advanced sensor settings, fine-tuning the hardware. If you look really closely at the back of the HC-SR501 board, you are going to see 2 tiny little orange dials with crosshairs on them. These are our potentiometers. The first one is the detection range adjuster. By turning this dial fully clockwise, you actually restrict the sensor's vision to a fairly short distance, about 3 meters. But if you turn it fully counterclockwise, it extends that vision out to an impressive 7 meters. Now, the second dial is the time delay adjuster. This one dictates how long the sensor keeps its output high after detecting motion. You can set this delay to be super short, like 3 seconds, or stretch it all the way out to a full 5 minutes. There's also this small physical jumper switch on the board, and that dictates the trigger mode. This is super important. In single trigger mode, if you wave your hand constantly in front of the sensor, the output will actually toggle off and on repeatedly. It basically rests for 3 seconds between every single trigger. Conversely, we have repeatable trigger mode. This keeps the signal high continuously for as long as you are moving. So the crucial point here is this. We highly recommend repeatable trigger mode. Think about it. If you're using this setup to keep a room's lights on, you definitely don't want the lights constantly flickering off while someone is just walking around in there. And that brings us to the really fun stuff. Part 5, application, auto door with servo. We are building a real-world project. Let's take everything we've learned and actually apply it to an automatic door. Thank you so much for joining me on this explainer. If you found this breakdown helpful, please do leave a like, subscribe for more deep dives, and keep building.